Integers are just any number you can write using digits and minus sign. So for example, rationals are basically the numbers that you can write as the divide of two integers. Minus 1 divided by 1 is a rational number. It's also minus 1, which makes it an integer as well, but it being an integer doesn't change the fact that it's also a rational number. And there are irrational numbers, which, as you may understand from the name, the numbers that cannot be written as two integers divided to each other. For example, pi or square rooted 5. Yeah, so those are sets of real numbers. All of them are infinite sets. If we want to give some more specific intervals, we need to use some notations. Most commonly known one is like that. So you most probably have seen such thing before. It means that the variable x is in between 2 and 4. It can be 2, but it cannot be 4. This is just like a geometrical line as well. This is also a way to write it. It simply shows you a geometrical line, one-dimensional line, where this is 2 and this is 4, and your x is in between somewhere here. Those two can be converted to each other very easily, because we haven't gave any special requirements for the x. It doesn't need to be an integer, even rational. It can be an irrational number as well. So what we can do is we can use this sign. That means is an element of. This is used for sets and an element. When I say x is an element of A, it means that the number x is an element of a set called A. So if A has, like, let's say 3 numbers, let's write it like that. X is an element of A and it's in between 2 and 4, then it means that it can only be 2 and 3. Some other signs that we can use with sets are those two. Now this sign means the union. It's used with two sets, let's say set A and set B. The union of those would create a new set, let's say C, and that would involve every element of. In sets you cannot have multiple elements that has the same value. You wouldn't have 6 elements, but you would have 5 elements, just like. And that would be the union of A and B, because you cannot have 2 trees in one set. That would be very meaningless, and changing the positions of the elements of a set wouldn't change anything as well. So the set
2, 3, 1, 4, 5 would also be equal to the set C.
The other sign means the intersection of two sets. It also requires 2 sets to use. So if I say the intersect of A and B, it means that I'm only taking the elements of both of these that are similar. So the intersection of those two would create another set. Let's call it Q. Would have the elements, or the element 3. The last sign is the subset sign. It just means the set at the left, let's say A, is a subset of the set at the right. Let's say R, because why not? That means that R involves every single element that A has. Now that we know the basics of the topic, we can get to a theorem that I want to talk about. Let's say x, y, and z are real numbers, and exactly one of the statements given here is correct. It can be x equals to y, x is bigger than y, or x is smaller than y, but only one of those statements can be correct. So let's go ahead and prove the statements that are given at top right. Starting with the first one, if x is smaller than y and y is smaller than z, then x would be smaller than z. Now to prove this, I will use something that I said previously. If you remember, I said that when you give an interval, you are also giving a one-dimensional line, a geometrical shape. And so we can just make a line right here. Let's say this side goes to negative infinity and this side goes to infinity. And you know, x is let's say somewhere, I'm going to do this red, is like here. And if we say that x is smaller, is less than y, then we should put y somewhere on the right side of the x. Somewhere here should be alright. And the second information given is that y is smaller than z, then y should be at the left side of the z. So let's say it is here, z is here. And we can clearly see that x is at the left side of z, which means that x is smaller than z, which is the thing we were trying to prove. So it is correct. Let's get to the second one. If x is smaller than y, then x plus c would be smaller than y plus c as well. I'm going to go ahead and put this in my line here. That should be good. Now, how do we understand if y is bigger than x when we are given such a shape? Well, the reason is that y is closer to the right side of this line than x is, and how much of a difference is there is calculated by y minus x. So we can say that if y plus c minus x plus c equals to y minus x, then the difference between the numbers have not changed, so the statement is correct. Now you can probably already see it. If you just put the minus sign in the correct place, it's going to be like minus x minus c, and then c's are going to be neutralized, so we are left with x y minus x at the end. So the second statement is correct as well. In third one, I don't want to use my line. it says that if x is less than y and c is bigger than 0, then cx would be less than c times y. And why this is correct is it can be simply understood by the concept of multiplying. Well, if you're multiplying two numbers, the amount, how much of a difference they're going to be is decided by how big the number you are multiplying is. So let's say 3 times 3 and 4 times 3. Now we multiplied those two by the same amount, 3, like the C right here, and what it made, this is equivalent to 9 and this is 12. Now the difference between 12 and 4 is higher than the difference between 9 and 3. And like it will go on like that. If I said 5, it would have been 25. And you know, 25 minus 5 is 20, 12 minus 4 is 8, 9 minus 3 is 6. So the bigger the number you're multiplying with, the bigger of a difference you're going to get. Now you may say that it wouldn't work with negative numbers. Well, yeah, I mean, let's say x is minus 8 and y is minus 4. In this condition, yeah, x would get much bigger of a difference, but we can, to understand why it would still work, we could say minus 8 is also 8 multiplied with minus 1, and minus 4 is 4 multiplied by minus 1. Now, if we multiply both of these numbers with c, we would get 8c times minus 1 and 4c minus 1. Just like we have wrote right here, so we would get a bigger difference in a positive way, because the c is a positive number, as the information given says. But the bigger your multiplier number gets, the smaller your number will be, because you're multiplying it with minus 1, which would reverse the whole thing and make it like the bigger the difference you get is, the smaller your number is as well. So in both conditions, the statement is correct. The last one I'm not going to explain. It's very similar to the last one, but this time it's a wrong statement. I want you to stop the video and try to disprove it by yourself. I want to finish it with an example question. Solve the inequality x squared plus x plus 1 is bigger than 7. Feel free to stop the video and try to solve it by yourself. I'm going to give 5 seconds. You better have solved by now. Now, let me do it. The best way to solve inequalities like this is to think it as an equation, and then once you found the x for the equation, you say that the x is anything that is bigger than the x that I just found, so that you found the correct answer. Now, if that was an equation, what we would do is we would just subtract 7 from both sides, and then we would have x squared plus x minus 6 equals to 0. Now, this is just quadratic formula that we have learned in the middle school. There are two x's. One of them is being subtracted. one of them is being summed. If you know the quadratic formulas, this is going to be -2, and that will be +3. And if you want, you can just stop the video and check if it's correct. I already checked it and then edited it out, trust me. And now that we have this, we just need to find what makes this 0, or we can just fix it and say what makes it above 0. Now, for it to be above 0, first of all, neither of those should be 0, because anything multiplied with 0 is still 0, and we don't want that. And one of those should not be negative, should not be sub-0. Why one of them? Because if both of them are negative numbers, then they would just, when they're multiplied, they will still make a positive number, which is we are still fine with. So as you may have noticed, we are going to have to give the answer in a form of intervals, because there are no unique sets of numbers that is writable. There are going to be infinite answers. So right now it seems like that it would be easier to find what x could not be than what x can be. So it cannot be in between 2 and -3, because let's say it's above x is bigger than -3 and smaller than 2, or smaller or equivalent to, yeah, that's also correct. Now if it's 2, it's going to be, left side is going to be 0, and that means this is not correct. And if it's below 2, let's say it's 1 for an example, this side would have been -1, because 1 minus 2 is -1, and this side would have been 4, and when you multiply those two, you get a negative number. If x was let's say 0, then this would have been -2, and this would have been 3, in which condition this is still below 0, because only one side of it is negative and the other one is positive. Now, why it shouldn't be above -3, it's because in any condition that x is below 0 but above -3, the left side will still remain as a negative number, because there are just going to be two negative numbers, and there's no way left side won't be negative if x is below 0. So both sides have to be negative for the result to be above 0. And if it's above -3, the right side won't be negative, which means the whole thing won't be bigger than 0. So now that we know x is not in between 2 and -3, involving 2 and -3, we can say that x is an element of such a set that goes to -infinity to -3 unioned with a set that is in between 2 and positive infinity. And this is the answer for our question. This video is actually made for me to be able to look back at what I did, so that I can remember the past topics about calculus and maybe linear algebra in the future. So if it surprisingly helps anyone else on the internet, I would like to see it in a comment or like a like, I guess. And yeah, hope I could have helped by anything. And goodbye.